Okay, so we've already finished this right here. So we're going to work with this equation right here. Just as a reminder, f of x is actually the same as y. So in this equation, it says y equals radical x minus 2, but I can still use that f of x function notation, so I'm allowed to use the definition of a derivative. So by definition, the limit as delta x approaches 0, fix that right there, when f of x plus delta x is subtracted by f of x all over delta x. So I'm going to plug this notation anytime I see the equation. Okay, so let's go ahead and do that. Just scroll down right here. So our first thing is to plug into the f of x plus delta x. So I'm going to get f, oops, my mistake. So what I'm going to get instead is radical, but instead of this x, I'm going to plug in x plus delta x. Then it tells me minus 2. Then I'm going to subtract f of x, which is just radical x minus 2, divided by delta x. Okay? Well, since this is asking for the limit as delta x approaches 0, what should I plug in to delta x? Correct, I should plug in 0. And if I do that, I'm actually going to get 0 over 0. So, just like I said from the previous problem, what happens when I get 0 over 0? I need to find where my hole is. So in this case, since I have radicals, I'm going to have to rationalize these radicals. So let's go ahead and take it to the next step. So I'm going to do radical x plus delta x minus 2 minus radical x minus 2 divided by delta x. But now to rationalize it, I need to multiply by its conjugate term right here. Right, divided by, same thing in the denominator, x plus delta x minus 2 plus radical x minus 2. Okay, so just like our previous section, I'm going to continue the steps, right? And I'm going to then solve for this. So I'm going to get x plus delta x minus 2 minus, and I'm going to keep this in parentheses since there's everything inside the radical. Right? So if I distribute, that's what I would get, all over, and I'm going to keep my denominator as its factors that were given. So I'm just going to copy all of these down. So if you take a look at this, if we distribute this negative, this becomes negative, and this becomes a plus. So if I were to simplify my numerator, this x is going to cancel with this x. This negative 2 is going to cancel with this negative 2. And what I have left over in my numerator, let me extend again, is delta x divided by delta x radical x plus delta x minus 2 plus radical x minus 2. So what do you notice about this? Correct? Now I can cancel these out and keep a numerator of 1. And if I continue, I'm going to bring back the limit notation. Delta x approaches 0, 1 over radical x plus delta x minus 2 plus radical x minus 2. So now what should I plug in to delta x? Good. I should plug in a 0. So if I were to plug this in, I'm going to get 1 over radical x plus 0 minus 2 plus radical x minus 2, which gives me 1 over radical x minus 2 plus radical x minus 2. And so I'm going to want to simplify my denominators here, and since they're both radical x minus 2's, I can combine them, and I get the equation radical x minus 2. So the derivative of this function is equal to 1 over radical x minus 2. Same steps as last time, except once I get to the limit point, I have an extra step of rationalizing. So let's see how else we can use these problems. And one of the ways is right here. So sometimes we're not just looking for a derivative, but it's just the first step to a more detailed problem. So according to this, it says write the equation of the tangent line to the graph of the function at the indicated x value. So in order to do this, we're going to have to go back into some prior knowledge, some concepts that you've learned in the past. So prior knowledge, and I'm just going to say K. So one thing I want to talk about is how do you write the equation for the line, for a line, right? A linear equation. So we've learned 3 different methods, but in this case, anytime you see this, especially in calculus, we will be using the point-slope form. So if you can recall, this is the point-slope form, right? So point-slope form is y minus y1 equals m times x minus x1. Right? So in order to use this equation, I need to have a slope, and I also need to have a point. Well, in calculus, we're still going to use the point-slope form, but instead of calling it slope, we need to make sure that we are calling it the derivative, right? So remember, by definition, the derivative is the slope of a tangent line. And so that's exactly what we're looking for. We need to find the slope for this actual line. I don't just want to know what the slope is, but I need the equation of the slope. And once again, I still need a point in order to do this. So let's start off with the simpler piece of this, right? Just to recall, this y and this x will always stay y and x. However, I'm going to need to plug in values for y1 and x1, which means I have to give you these values or you have to find them. So according to our example, it says y is equal to 1 over x and x is equal to negative 3. So right here, they're telling me your x is actually equal to negative 3. So I can easily plug in that negative 3. So let's do this. I'm going to write our equation out. I'm going to color code it. Equals times x minus, and I'm going to put in a spot for the derivative right here, and I'm also going to put in a spot for the numbers right here. So according to this, my x is negative 3. Since it's a negative 3, that's going to change this to a plus 3. But I need to find this y. So how can I find y with the information given? Good, I'm going to plug it in. So I get y is equal to 1 over negative 3. Sorry, that's an equal sign right there. And so simple enough, my y is actually equal to negative 1/3. So I'm going to plug that in, and since once again it's a negative, this becomes a plus, and I get a 1, to make this easier, 1/3 for you. So the only thing missing is our derivative. So what I'm going to do is we are going to calculate the derivative the same way that we did the previous problem. So once again, the derivative is equal to the limit as delta x approaches 0 of the function. So our function right here is 1 over x. And so I'm going to do f of x plus delta x minus f of x over delta x. So if I start to do the work for this problem, our equation says 1 over x, so instead of x on the first part, I'm going to plug in x plus delta x, right? Then I need to subtract f of x, which is 1 over x, and finally I have to have a delta x in my denominator. So once again, just like our previous chapter, we're going to have to solve this using algebra. So if I wanted to get common denominators, I need to multiply this one by x over x, and this one by x plus delta x, so my denominators match. And if I simplify that, I'm going to get x minus, parentheses, x plus delta x, all over x plus delta x, parentheses, times x. And don't forget, I still have that denominator of x from here. Okay, so we're going to have to work on simplifying this. So I'm going to simplify my numerator, and I get x minus delta x all over x times x plus delta x. I'm just moving this delta x over to that side. And since I have double denominators, I can actually combine my denominators into one. I'm going to stick that delta x right here. So let's continue and simplify our numerator right here. If I simplify my numerator, this x right here is going to cancel this x, and what I have left is negative delta x divided by x times x plus delta x times delta x. And once again, what do you notice about this problem? Good. I can cancel these x's out, delta x's, excuse me, and that's going to give me a 1 on top. And if I continue this, I get negative 1 divided by x times x plus delta x. And don't forget, we're not done because we need to take a look at the limit as delta x approaches 0. So what should I plug in for delta x? Correct, I need to plug in 0. So I get negative 1 divided by x times x plus delta x plus delta, plus 0 gives me negative 1 over x squared. Okay. So you're not done there, because what we still need to do is we need to find the actual value. So if I scroll back up to our work, I need to find the missing number that goes in here, right? So what it's saying is, I have the equation of f of x here. F of x, what we just solved, is equal to negative 1 over x squared. Well, to get the actual value, don't they give me the x I'm looking for? I'm going to look at this when x is equal to negative 3. So I'm going to just finish this off and say f of negative 3 is equal to negative 1 over negative 3 squared, which gives us negative 1 over 9. So according to this, the slope needs to be negative 1 over 9, which I can then plug into the equation right here. So just to make it clearer, I'm going to write the final answer right here. And our final answer is y correct. Y plus 1 over 3 is equal to f prime of x, which is this right here, negative 1 over 9 times x minus negative 3, which is plus 3. And now you have the equation of the line tangent to the curve. And that completes our lesson for today. Thank you, ladies, and we'll continue on Monday. See you then, and have a great